Hi, this is Dr. K A TPGIT. In this video, I am going to discuss about the design of worm gear drive. Worm gear are used to transmit power between non-intersecting shaft whose axes are at right angle to each other. The worm gears are best suited for the applications where a uh, great ratio reduction is required between the driving and the driven member. The ohm is the cylinder. This is actually a ohm. This is a cylinder upon which the teeth are cut at a single or multiple start acme type thread. The pressure angle of this thread ranges from 14.5 to 30 degrees. As the lead angle of the ohm increases, greater the pressure angle is on the side of the thread. Where ohm is the driver gear, which is acting as an input, and the driven gear that is which is referred as output, which is called ohm gear or ohm wheel. The teeth on the ohm gear are cut to confirm whether the teeth on the ohm. Then this is the nomenclature of ohm gear. This is actually ohm and this is ohm gear. Here the number of thread resembles the number of start. This is actually lead triple, and then the phase width is addendum. Then here the pitch circle diameter. Here the pitch circle diameter, the starting point must coincide with the pitch circle diameter of the ohm wheel. So here the pitch of the ohm is the distance measured axially from a point on one thread of the ohm to the corresponding point on the adjacent thread. That's already we know. The pitch of the ohm is equal to the lead divided by the number of threads or the start and the ohm. That is the relations among the pitch and the lead in the bevel gears. See, actually the lead is the distance that one advances in complete revolution of the ohm. That means in one complete revolutions of the ohm, of the distance is moved inward. That is the lead. So the lead is equal to the pitch of the ohm multiplied by the number of ohm threads are started. The started means the number of thread on the ohm can be one or multiple. A single thread ohm can be referred as having a one start. So ohm here ratio is determined. This actually based on the number of teeth on the ohm gear by the number of start on the ohm. Now the pitch diameter of the ohm. Here the pitch diameter of the ohm is the diameter of the circle which is tangent to the pitch circle of the matting gear in its midpoint. So the pitch diameter of the ohm should be as small as is consistent with the necessary strength to minimize the rubbing speed. Then ohm contact. Two types of ohm gearing sets which have a different contact pattern when the ohm and ohm gears are in their proper positions. That is, these two types of contact are referred as non-threaded, non-throated and throated, of which there are two styles, that is single throated and double throated. In ohm gearing and self-locking. So the self-locking facilities are available in the ohm gear drive. So here the ohm gear sets are employed for speed reductions and have the ability to self-lock when a backward motion is attempted. That means it is difficult to rotate the output shaft in reverse rotation because of high lead angle ohm that can be of single or double threaded design. So when the ohm gearing is self-locking or reversible means the ohm gear cannot drive the ohm. So the ohm gear drives can act as a back steps on an inclined belt and chain conveyor. So the self-locking action of the gears will prevent heavily loaded conveyor from the reversing back down on the inclined slope when the driver has been stopped. In zero backlash, minimum backlash or zero backlash is important for the bevel gears. worm gears. Minimum backlash is important in the applications where the timing, indexing, and certain instrumentations equipped have to be functionally precisely equipped. So with this introductions, I go for how to solve the problems on the design of worm and worm wheel drives. Here, worm and worm wheels are different compared with the, so far we discussed, that is spur gear, helical gear, and worm, bevel gears. Here, one is a cylindrical in worm gear drive, one is a cylindrical type, another one is a gear type. And one in worm type, there is only a number of start and number of thread, not in a number of teeth. Whereas in a worm gear, we consider the number of teeth on the worm wheel. Okay, so let's see in the problem. Design of worm gear drive to transmit 20 kilowatt at 1440 rpm. The speed of worm wheel is 60 rpm. Here the worm wheel, that is the speed of the wheel, is 60 rpm only. So from 1400 rpm it is reduced to 60 rpm. So the worm and worm gear drive arrangement is especially used for the speed reducer. So from this, first write down the given data. So the power transmitted is 20 kilowatt. The speed of the worm N1 equal to 1440 rpm and speed of the worm wheel N2 is equal to 60 rpm. Here the speed ratio I is equal to 24. Here the speed ratio I, here it is not equal to N1 by N2. We should clearly remember that in worm gear drive, the speed ratio is not equal to N1 by N2, which is equal to number of teeth on worm wheel by number of start on worm. Okay, number of teeth on worm wheel divided by number of start on the worm. Okay, as well as in the previous problems, here also the first step is the selection of material. In a data book at page number 8.45, the worm is always steel only. The the material of the worm is always available in steel. But worm wheel are available in two cases, either bronze or the cast iron. Okay, so based on the velocity and then the types of casting, the types of manufacturing method, whether the castings or forgings, and then the treatment method, we can select the sigma C and sigma B. We always prefer the sigma C and sigma B for the worm wheel only. Okay, so from the page number 8.45 for worm wheel material bronze, here I have selected sigma C as 159 Newton per mm square, sigma B as 78 Newton per mm square. Then the second step is center distance. Maybe it is not a non-intersecting and non-parallel. There may be some particular distance between center to center. So here we should consider center to center, which is available at page number 8.44. So A is equal to Z2 by Q. Here the Z2 is nothing but the number of teeth on the worm wheel. Q is some constants that is initially assumed as 11, which is available at page number 8.44. Then the cube root of 540 by Z2 by Q, sigma C and MT. Here all the values are known except Q and MT. Okay. Here I is equal to 24 and based on this we should find out. Initially Z1, that is the number of start on the worm, is assumed based on the velocity. So we generally assumed Z1 is equal to 3 since it can be ranged from 1 to 4. So within this we can select. Here I assumed as Z1 equal to 3. That means number of start on the worm is 3 and then Q is equal to 11. So now we are going to discuss how to determine the design the MT for this. Okay, from page number 8.44, the designed thrusting moment MT is equal to MT into K dot KD. Okay, so here we should note it down. Another difference in the worm gear drivers, MT, that is the torque transmitted by the pinion P is equal to P into 60 by 2 pi N. This is only for, so far we discussed either bevel gear, spur gear or helical gear. But in the case of ohm gear, we should also consider I in the efficiency of the gear drive, right? So, or we can use 97420 into kilowatt by N1 into I into eta. This formula is available at the page number 8.44. This is the difference from the other drives. Here, so far we discussed two main difference. One is speed ratio I, that is equal to the number of teeth on the ohm wheel by number of stopped on the ohm. Then the another formula for determining the torque on the pinion by using the other formula, not a general formula, which is also available at the page number 8.44. Then at the page number 8.46, we assume Z1 equal to 3. So for Z1 equal to 3, and similarly eta is equal to, initially we assume 0.85. 0.85 I is equal to, we can find out Z2 by Z1 equal to 24. So from this 24 as given in the problem. So from this Z2 is equal to 24 into Z1. Here Z1 we initially assumed as 3. So Z2 is equal to 72. So now the number of teeth on the ohm wheel is 72 only. So by using this, now we can calculate the MT. Then I designed K.KD. So the K.KD can be predicted from the page number 8.44. Here is always K is equal to 1 and KD is equal to 1 for the velocity is less than 3 meter per second. So by using these parameters, we can find out designed MT is 2546 into 10 power 3 Newton per mm square. Then substitute all these values in the center distance formulas. Now A is greater than or equal to 309 mm. Then the next step is minimum module. The formula is available at page number 8.44. Here also we should carefully select the formulas for center distance and the minimum module for the ohm and ohm wheel at the page number 8.44. So here the unknown parameter is again YV. So the YV form factor for here also it's a visual number. We imagine as this is the imaginary spur gear. So we go for the visual number of teeth. So the ZV2 is equal to, since V2 means here the driven member is a wheel. So 2. So ZV2 is equal to Z2 by cos cube gamma. The gamma is nothing but the lead angle of the helix. So here the formula is revised from Z2 by cos cube gamma, cos cube instead of cos del. Here we have a cos cube. So from the page number 8.44, gamma is equal to tan inverse of Z1 by Q. So we know all the values from this lead angle equal to 15.25. So we can get a ZB is equal to 80. So from page number 8.18, as usual in previous designs of other drives, so ZB1 equal to 80, X is equal to 0, YB we can get it as 0.499. By using all these values, then minimum module which is greater than or equal to 6.2, or from the page number 8.46 or from page number 8.2, we can identify the next standard module X is equal to 8 mm. Then the character center distance. Similarly, at page number 8.43, we have a formula for the character center distance. Here we have all the values. So by substituting, then we can predict it as 332. Again, the checking of sigma C and sigma B. This is actually similar with the other drives. Here the sliding velocity formula including the slightly changes in here it includes cos gamma. So and by using this relation 6.82, hence this is a greater than, here the another condition, sliding velocity is greater than 3 meter per second. The sigma c is reduced by 20%. So initially we have a 150, now it is reduced to 140 something. Then based on the VS, the sigma C can be selected as new designed sigma C is equal to 149 Newton per mm square. So from the page number 8.4, we have a formula for sigma B and sigma C. Now by using the revised values in the sigma C and sigma B, we can find out the sigma C value. Here the sigma C value is 148.5, which is less than the designed sigma C, that is 149. Similarly, sigma B is find out as 25.91, which is also less than sigma 4. So the design is safe. Now, based on the other parameter from the page number 8.48, so we will discuss it in the next section, next video. Thank you.